Good afternoon, welcome to our latest edition of Science with Mama J. Today we're going to be talking about gravitational potential energy specific to a lab that we've been performing over the last couple of days. So in the lab that we've been performing, basically we had a series of rods. They were steel rods and aluminum rods, one short and one long of each, and we used them to drive a nail into a piece of styrofoam. And our goal was to determine which combination of rods and tubes would help us to drive the nail in the most. So which one would apply the most energy to the nail to drive the nail in the furthest. And the tubes were clear plastic tubes that basically functioned as guide tubes, but we had a short one and a long one, so we were able to adjust the distance as well. And we were able to determine during this experiment that the long steel rod and the long tube drove the nail into the styrofoam the furthest, and the short aluminum rod and the short tube drove the styrofoam in the least. Now, we normally do not work with two independent variables at a time, and we were working with the independent variables of mass and height. However, in this particular case, we were able to look at both of them separately. So we were able to look at four different masses: the mass of the long aluminum rod, the short aluminum rod, the long steel rod, and the short steel rod, as they behaved in the long tube, and then as they behaved in the short tube. And we were able to look at each individual mass and assess the height as they behaved in the short tube and the long tube. We were able to see how the masses behaved in the short tube and the long tube. So looking at the individual masses and in one particular height, we were able to assess how mass alone impacted. And looking at the same mass of a rod, let's say for example, the long steel rod in the long tube and the long steel rod in the short tube, we were able to determine how height on its own impacted the force that drove the nail, and in the other case, how mass impacted the force of the nail. Now, this is extremely important because we have to understand how gravitational potential energy impacts forces. So, first of all energy is calculated in joules. Okay, let me go ahead and give you that. Okay, joules is the unit for energy. And I'm going to go ahead and actually give you, although I didn't do it earlier, I'm going to give you the gravitational potential energy formula as it is written in its appropriate units. So GPE, gravitational potential energy in joules, is equal to 9.8 newtons per kilogram meter times the mass of the object in kilograms times the distance change. So, and this is in meters. So the distance change means how far it falls. Okay, so in this particular case, what I did was I took the measurements of all of the rods, and I also took the masses. Not the rods, I'm sorry, the tubes, and I also took all the masses of the rods. So to see how this worked out, if we look at the long rod, okay, so the long rod and long tube, okay, 9.8 newtons per kilogram meter, newtons per kilogram meter, times, oh boy, I'm batting 1,000 today, meter, times the mass of the rod. So the mass of the long steel rod was 100.24 grams, but we must convert it to kilograms. So 100.24 grams is 0.10024 kilograms, and times the change in distance. And in this particular case, the change in distance in the long tube was 20.4 centimeters, converted to meters is 0.204 meters. Okay, and when we did the math for this, and we're going to go ahead and do the math together again, it was 9.8 times 10024 times 0.204. Go ahead and backspace. And that gives you, so the GPE is equal to 0.20 joules. Okay? Now, looking at the second one, it's the aluminum rod, the short aluminum rod. So I went from one extreme to the other. So the short aluminum rod with the short tube, the gravitational constant, so GPE was 9.8 newtons per kilogram meter, times the mass, which for the short aluminum rod was 17.89 grams, converted to 0.01789, times the distance fallen. It had a tube distance of 10.2 centimeters, so 0.102 meters. And when we did this math, it was 9.8 times 0.01789 times 0.102, and that equals a GPE of 0.0179. Okay? Joules. So as you can see here, just by looking at this data, looking at the combination that produced the most energy based on the data that the classes posted, and the one that produced the least energy, you can see that the gravitational potential energy of 0.20 joules is far greater for the steel rod in the long tube than the gravitational potential energy of the short aluminum rod with the short tube at 0.0179. Okay, so the greater the gravitational potential energy, the greater the energy that's going to drive the nail, the further the nail is going to go. So, if we look at our setup, so let's go ahead and look at our setup. We had a block, okay, and in that block we had a nail, a flat-headed nail, and then we had a rod that was released and driving towards the nail. Well, at this point, before the rod is released, the gravitational potential energy of the rod is at its maximum. Okay? The kinetic energy of the rod at this point is 0. Now, as the rod falls, the gravitational potential energy decreases, GPE decreases as the rod falls. And KE increases as the rod falls. Now here, just before before the point of impact, KE is at its max, and here the GPE is 0. So as you can see, there's an inverse relationship of gravitational potential energy and kinetic energy. As the gravitational potential energy decreases, the kinetic energy increases. And as the kinetic energy decreases, let's say, for example, if you're throwing a ball up in the air, okay, you'll see the ball as I throw it up in the air. It slows down, it stops, it turns back around, and it comes back towards me. So as the ball is rising, it is decreasing in kinetic energy because it's slowing down. It's increasing in gravitational potential energy until it stops. And then as the ball begins to descend, its gravitational potential energy decreases and its kinetic energy increases. At the point where it stops at the top, its GPE is at its max, and for that moment the KE is 0. And just before the ball hits my hand, when I catch it, the kinetic energy is at its max, and when I catch it, its gravitational potential energy is 0. So I hope that made a little bit of sense. Now, one more thing I want to do is just go over some of the points. We talked about already the two variables that impacted, the independent variables that impacted how much the nail was driven. That is the mass of the rod and the height from which the rod fell. The dependent variable, of course, is how far did the nail get driven in. So what distance the nail was driven in, okay? We must keep the distance that it falls the same. So if I'm using the long rod, I have to drop it from the same point every time. Okay, so just to give you an idea of what I mean by that, this is an example of the rod that we were using and the tube. The tube is clear, you might have trouble seeing it, but you don't want to start here, for example, and then here, and then here. You must keep it at the same point every single time you drop it. And the reason for that is because if you consistently change your starting point, you're changing the height from which it falls, and obviously you're changing the gravitational potential energy behind the rod, so your results are constantly going to change. Okay, you only want to alter one variable at a time. And if you are keeping the height consistent, obviously you're measuring 4 different rods, you're changing the mass. So you want to keep it the same because you want your results to be consistent. So as you're doing multiple trials on the same vein, if you're conducting multiple trials in an experiment, the reason you conduct multiple trials, and it is encouraged that you conduct multiple trials in every experiment you do, the more trials you conduct, the better your results are, because then you can identify any errors that you've made and you can make sure that your results are consistent. You want to see consistent results. If you're getting wildly different results, the experiment is not valid. You want to see your results to be relatively close to each other. There is a certain amount of human error. You're not expected to get the exact same number every time, but there's a big difference between getting 0.9 and 1 and getting the nail driven completely in on the first shot and then doing the exact same trial again and not budging the nail at all, using the exact same height and the exact same rod. So if that happens, clearly something is wrong because those results are clearly outliers. Okay, so you're looking at quantitative data, okay? Qualitative data is data that is basically information that you're getting via observation, what you're looking at. Is there a color change? Is there an odor? Okay, am I observing that the substance is changing some kind of a state? That's qualitative data. But quantitative data is numerical data. And if you look at the data table that you took during the course of the lab and the class table that we posted, that table is definitely quantitative, okay? Quantitative, quantity. So quantitative data is definitely numerically based, okay? So we've pretty much discovered everything we need to know in regards to our quiz. We've talked about all sorts of types of data, the variables, the independent and dependent variables. So hopefully some of your nature of science benchmarks will make a little bit more sense to you as you apply them to this lab. Make sure you're paying attention to what the question is asking. The quiz is fairly straightforward, but hopefully it'll make a little bit more sense to you. And hopefully those of you who are not in my class but are watching, gravitational potential energy and kinetic energy makes a little bit more sense. If you have any questions, please feel free to send me a comment and let people know about our page, because we want to help as many students as we want improve their understanding of science. It's great to see you again, and welcome to the new year, and I look forward to talking to you soon. Have a great night.